good morning or afternoon or evening or midnight to you, depending on when you're watching this, obviously. In the last video, you learned about the idea behind confidence intervals. Here you're going to learn about the structure of reporting confidence interval inference. So this video is more about how you propose your answer, less about how you understand it. So, let me speed things up a little bit. The first part is state, and we're going to take a look at means and proportions for every part. The first step is to state what we're going to do. So for means, we say we're going to construct a blank percent z interval for the true mean of blank. For proportions, we're going to do the same thing. We're going to construct a blank percent z interval for the true proportion of the variable we're studying. So we might choose 95% confidence, we might choose 90% confidence, or 99% confidence. And the mean might be the average heart rate of 57-year-old males, or proportions might be the average, or the proportion of high schoolers that will get into a car accident in the next year, something like that. So up next is going to be the plan part. Now we need a couple of things. So first of all, from sampling distributions, we need a normal distribution. So that's why our n has to be greater than 30 for means, and np hat greater than 10, n times 1 minus p hat greater than 10 for proportions. These conditions right here tell us normality. That means the sampling distribution that we're studying is normal. We also need an SRS because, randomness is important from statistical design. We also need independence of our trials. We want to make sure that one trial is not affecting the other. And for means, we need sigma known. For proportions, we don't need sigma known, but rather we'll calculate sigma as square root pq over n, or square root p times 1 minus p over n. The last part of the plan section is to take all of the data that we know and write it down. So what is x bar, what is sigma, what is n? So we can use that in the next part. So after we plan, it's time to do. For means, the confidence interval is x bar plus or minus z star times sigma over square root n. We talked about that in the last video. For proportions, p hat plus or minus z star times square root pq over n. So there you go. Alright, so when we're concluding, that's our last part, our conclusion. For means, we're saying that we're a blank percent confident the true mean is of whatever the mean is between blank and blank. So I'm 95% confident the true mean of 57-year-olds' heart rates is between 100 and 120 beats per minute. For proportions, I could say I am 95% confident the true proportion of teens that will get into a car accident in the next year is between 15% and 20%. Alright, this should help you with the structure. Make sure you review this video and the video prior to this so that you understand the theory and the reporting of confidence intervals.